Flaps and slats come into play at the most delicate moments of flight, when aircraft needs to fly slowly without losing lift. They do not attract attention like engines or wings, yet they are silent protagonists during takeoffs and landings. When the aircraft is still on the ground, they appear to be nothing more than fixed parts of the wing. However, as soon as the pilot activates them, these surfaces reveal their true purpose: to transform airflow and allow a machine weighing tens of tons to overcome the limits imposed by physics. Flaps are located on the rear portion of the wing at the trailing edge. When extended, they increase the wing's curvature, altering the path of the air flowing over and beneath it. This seemingly simple movement produces a profound effect. The wing begins to generate more lift at lower speeds. In practical terms, this allows the aircraft to take off from shorter runways or land more safely, reducing the speed required to remain airborne. It is as if the wing temporarily grows, becoming more efficient precisely when it is most needed, during takeoff. Flaps are usually set at an intermediate angle, neither fully retracted nor fully extended. This configuration offers a balance between additional lift and manageable drag. As the aircraft accelerates down the runway, airflow intensifies over the wings, and the flaps help the airplane lift off earlier. Once sufficient altitude and speed are achieved, the flaps are gradually retracted, restoring the wing to its clean, efficient shape for cruise flight. During landing, flaps play an even more noticeable role. They are extended in stages, significantly increasing lift while also adding drag. This extra drag helps reduce speed without requiring abrupt maneuvers. The aircraft descends in a controlled and stable manner, almost as if it were being gently held by the air. The smooth touchdown on a runway is a direct result of the interaction between flaps, airspeed, and precise pilot control. Slats, located on the front portion of the wing at the leading edge, serve a different yet complementary purpose. When deployed, they create a small gap between the slat and the main wing. Through this slot, high-pressure air from beneath the wing is directed to the upper surface. This airflow re-energizes the air moving over the wing, delaying stall, the condition in which the wing loses lift due to an excessive angle of attack. In practical terms, slats allow the wing to operate at higher angles without losing effectiveness. During slow and steep approaches, such as those required at airports surrounded by obstacles or with short runways, they are essential, while flaps increase lift by changing the wing's curvature. Slats ensure that this lift is maintained even in critical conditions. It is a quiet partnership, yet a vital one. In many modern aircraft, flaps and slats are deployed in a coordinated manner. The pilot selects a position on the control lever, and hydraulic and electronic systems take over, extending each surface in the correct sequence. Sensors monitor position, speed, and configuration, ensuring everything operates as intended. This automation reduces crew workload and enhances safety, but it does not replace the engineering knowledge behind the system. Every movement was calculated by engineers who studied airflow in wind tunnels and simulations, analyzing how air behaves during each phase of flight. There are different types of flaps: plain, slotted, Fowler, among others. Some simply rotate downward. Others slide backward before descending, further increasing wing area. This variety reflects how aeronautical engineering seeks to extract maximum performance from a single surface. Slats also vary. They may be fixed, movable, or automatic, depending on the aircraft design and mission. During cruise flight, at altitudes of 10,000 to 12,000 meters, flaps and slats remain fully retracted. The wing assumes its cleanest shape, ideal for efficiency and fuel economy. At this stage, they seem almost forgotten. Yet as soon as the aircraft begins its descent, they are prepared once again, like actors waiting for their cue. In this way, flaps and slats represent the aircraft's ability to adapt to different phases of flight. They demonstrate that flying is not merely about moving through the air, but about interacting with it, shaping it and respecting its limits. Without these movable surfaces, modern aviation would be far more restricted, requiring longer runways, more complex operations, and narrower safety margins. With them, the aircraft becomes versatile, precise, and reliable, capable of smooth takeoffs, graceful landings, and of turning physics into a silent ally on every journey.